So today we're going to talk about minerals, and we're going to do the STEMscopes Minerals Lab. Here's our mineral collection that came with it, so you can see some of the differences in how they look and different qualities that they have. This is mica. One of our vocabulary words is cleavage, and this is one that actually will split into thin sheets, and so that's what mica looks like. We don't have any other samples of it other than that one. But we're going to talk today about minerals, and we're going to do the minerals lab. So you should have your student journal, and you should have a copy of the student guide so that you can follow along as I go through this. First thing we're going to do is we're going to test for the hardness of each mineral. And as you read in the description here about hardness, we figure the hardness of a mineral and we compare it to the hardness scale, Mohs hardness scale that's listed right there. Fortunately, we have a set of minerals that are set up in Mohs hardness scale. Everything from a 1, which is talc, where it's actually so soft that you can scratch it off with your thumbnail, all the way up to number 9 up here, which is corundum, which is hard enough that it could scratch glass. And so we have our whole set there compared to these 9 minerals, and then diamond being the 10th one. So we're going to do our hardness test on our mineral. Today we are looking at this mineral, and we will identify it at the end. But this is the one we're going to go through all of our tests for today. So our first thing that we do on our procedure is that we try to scratch it with our thumbnail. So I'm just going to scratch it with my thumbnail, and no, it does not scratch easily with my thumbnail. So that would mean it is not a 1. It's not comparable to talc on the Mohs hardness scale. It's not a 1, it's greater than that. So then I go here to the second step. Try harder with your thumbnail, it says. So I try harder, and still it hurts, but it does not scratch the mineral. So it's not going to be a 2. It's going to be harder than gypsum. So then my next step is to try to scratch the mineral with a penny. So I take my mineral and I scratch it with a penny, and still nothing. So that means that it is not a 3. It means it's harder than calcite. So I go to the next step. So I try to scratch it with a nail. So I have my nail. I'll try to do this still holding the camera. And as I do this, it does actually scratch this mineral with the nail. So that means that this mineral's hardness is somewhere between a 3 and a 4, because it didn't scratch by a penny, but it was scratched by a nail. So this mineral is somewhere between a 3 and a 4. We don't know exactly, so we're going to say it's about a 3.5. If that didn't work, then we would move on to the next one, and I believe we would try to scratch it harder with a nail, or difficult to scratch with a nail. Then we would use a steel file like this to try to scratch it, because that's even harder. If that doesn't work, then we try to scratch glass with it. If it doesn't, or if it easily scratches glass, then we try to scratch the steel file with it. So we continue running through these tests to determine the hardness of the mineral. Well, we're finished with our mineral because we've come up and it is a 3.5 to a 4. So go over here to your lab report, fill in this first box right here. We're just going to do 1. And so we're on hardness, 3.5 to 4, and then you're going to answer these 2 questions. What is hardness? And then describe the process you use to determine a mineral's hardness. So in this area, you're going to describe these steps that we just followed here in the hardness test. So you might want to pause at this point to answer those 2 questions. So our next step is the color, transparency, and crystal shape test. So we look at our mineral and we determine what color that is. So we might say it's white, tan, there's a little bit of gray in there, but I think we're pretty much on the off-white or darker shade of white. So that was easy. So then we go to transparency. Transparency, according to our guide here, talks about the ability of light to pass through. So if it is transparent, we can see through it. So like this mineral, if you notice, we can see the pictures right through this mineral. So this one is transparent. You can see through it. A second type is translucent, which means that you can't see through it, but light will pass through it. So this one, there's what the mineral looks like just sitting here on my desk. And then when I put the light on it, the light shines through, but I can't see through it. So it is translucent. And then the third type that we have is opaque, which means that you cannot see through it. And light does not pass through it. As you can see, it completely hides the flashlight. So our mineral is going to be opaque. And so I go over here to my color transparency, list my color, list that it's opaque, and then I'm going to go, oh, we didn't do our crystal shape. So our crystal shape, we're looking through the hand lens, and this is going to be really interesting to try to do on camera, but we look through the hand lens, and we try to see the shape of the crystals in the mineral. So that's really hard to do on the GoPro, especially with me trying to hold it, but we would look for crystals, and we would compare it to a list of crystal shapes like this. So did we see a cubic shape? Did we see a tetragonal shape, triclinic shape, this shape, orthombic? Is it hexagonal? Is it monoclinic, or is it trigonal? Well, I'll give you a second to try to figure out what you think it is. And then if we looked at it closely enough and we spent enough time trying to view the crystals that are on there, we would see, or we would know, that this one actually has a trigonal shape crystal for this mineral. So we go over here to our crystal shape, and we're going to put trigonal for our crystal shape. If you guessed any of these with the triangles and the cubic shape, you're pretty close. So that one's a very difficult one to see. So now we're going to go over here and we're going to answer these questions on the color, transparency, and crystal shape. So you might want to pause at this point, answer these 5 questions. Use the information in your student guide in order to answer those questions. Okay, so our next test is the luster test. And you can see we learned back with metals, nonmetals, and metalloids what luster is. So we have a definition of luster. And we learned just shiny and dull back then. Now we're going to be looking more at different types of dull. So we have earthy, we have resinous, we have waxy, we have glassy, we have pearly. These are all different ones, and you can see the definitions for what those look like. So as we look at our luster of our mineral that we've been testing, would we say that is metallic or dull? Or is it, if it's dull, what type of dull is it? Is it earthy? Does it look like dried mud? Is it resinous? Does it look like dried glue or plastic? Is it waxy? Does it look like the surface of a candle? Is it glassy? So it looks like glass, or is it pearly, more like a pearl? So take a second to figure that out. See what you think there. Okay, and for this one, oh, and then there is a whole list of different lusters. So this is just dull. It's hard to see with the video on the computer. But then vitreous, silky is another one, metallic, earthy, greasy, resinous. So that kind of, you can see that looks like dried glue, plastic, waxy, pearly, and adamantine. So this one actually is pearly, our rock, and you can kind of see our mineral has that same quality, even with the computer. So this one is pearly. So we go over here on our chart that I've turned the page already, and we fill in our type of luster is going to be pearly. Okay, our next test, oh, and then you'll want to answer these questions. So what is luster, and then define all of the different types of luster that we just discussed. So you might want to pause at this point and answer these questions using this information right here in your student guide. So our next test is the streak test. And the streak is the powder that's left behind when the mineral is crushed or rubbed on a streak plate. So just happen to have a streak plate here. And what we do is we take our mineral and we run it on the streak plate, and it should leave a powder behind. So if you look really closely there, you can kind of see it. See the powder left behind? And what color is the powder? So the powder left behind by our mineral is white. So that's pretty consistent with the color of the mineral. So you'll go to your student journal, fill in the streak color as white, and then you're going to answer these questions about streak here. But let me just show you that we have this one. This is pyrite that we saw over here in the metallic luster screen. And this mineral is more of a gold, gray, green color. But then when I run its streak, you can see its streak is either a dark gray or black. So the streak color does not always match the color of the mineral. So if that helps you with this question, because it says which minerals, we're only doing one, but if you'll notice that they don't always match. So this is not, well, this is a good way to tell because the streak is always the same, but you're not going to be able to say, oh, it's white, so the streak is going to be white. So take a minute and answer your questions here about the streak test. Remember to use your information in the student guide to help you do that. And you might want to pause at this time to answer those questions. So our final test is the density test, and we hopefully from the beginning of the year remember how to calculate density, and so we given the information about density, and since we're only going to do one, it doesn't really, we don't need this chart, but so I have my digital scale over here. Make sure it's at 0. It's at 0. So my mass is 40. My mass is 40. That's easy to remember. And then I have set up my water, and I have put 150 milliliters of water in there. So when I set my mineral down in there, I'll wait for that to quit jiggling. It has gone up about 15, 20, say 20. So our mass is 40, our volume is 20. So the math should be pretty easy on this one. So 40, our mass divided by our volume of 20 equals 2. So our density for this mineral is 2. So we go over here. This one, it says list the mystery minerals in order. We only did one, so if you could describe the process that you use to calculate density. And then over here on your student guide, your student journal, then you're going to list your density as a 2. And the actual density for this mineral that we're calculating, the actual density is 2.84. So you may want to think about what could have caused the density to be so different between what we recorded here versus the actual density of it. And it has to do with the fact that we're using a beaker to get the volume as opposed to using a graduated cylinder. So our density is actually 2.84. And then we already answered this. For me, for my classes, we're not doing this. We will use this maybe in the virtual lab, but you can cross this out. We don't need this part of the student journal. So hopefully you've filled in everything up to this point. There are mystery mineral. And then you're going to, after, I would say after you do the virtual lab on STEMscopes, that you would fill out the reflections and conclusions to give your opinions and talk about the process for testing minerals. Our mystery mineral that we've been looking at this morning is dolomite, and so it has all of those things. It is white, it is 2.84 density, it has a pearly luster, it has a white streak, it has a hardness of 3.4 to 5, and it is opaque, And so we have, and it has a trigonal crystal structure. And so it fits all of the things that go along with dolomite. So we know that this mineral that we've identified this morning is dolomite. And that should be the end of the minerals lab.